So, hey, this is Rob again. We're going to do another quick and dirty video. For me, that's about 2 hours probably. I don't know. We'll see. And if you don't know Unix header tail are these programs that show you the top, 5 lines of a file or the bottom so many lines of a file. And so we're making a YouTube video right now. So if you're welcome if you're on Twitch watching live. I have the chat off for now just to keep the YouTubers from getting distracted or the risk of somebody saying something stupid and making the video die. So we're just gonna jump right in. So I actually have another place to put this code that I need it, but I'm going to do it as I do all the projects as if you're just starting a Go project from the first time. So this is repetitive. If you want to fast forward over this, that's fine. But if you've never made a Go project, we're going to do Go from scratch. And you can go ahead and ask questions along the way, and people in the chat can maybe answer them for you in the comments. But I'm just going to annotate what it is I'm doing. So the first thing you need to have is Linux installed. You need to have a terminal. I'm using Windows with a virtual machine using VMware, and it's all covered in the boost. And then we're gonna have, how's it going? And then we're gonna have we're using Vim and Tmux as our editor, and we've got Vimgo installed, and that's the only thing that we have installed in here to be able to help us out. We have the regular Go tools, like we have a testing tool and everything, and I'll try to talk about those as we go through. So that stuff's all covered elsewhere, but I just have to summarize it for the beginning people who haven't heard it before. So what is the first thing you need to do? You need to get into a repo directory. GitHub.com /RWXRob is the way I organize my repos because, reasons. I want to be able to do it, and I need to make a new repo. So we're making a new repo. Let's call it, we'll call it Git and, what should we call it? Head tail. How about that? I'm going to delete it later. So just so you know, git repo create head tail. I mean, I already have another repo called a file or file system package for this kind of thing. So, I mean, you could make it util. Should we call it util so you can put other things in there? What do you want to call it? Mine's already called. Let's call it util. I mean, I don't like making utils though. I don't. And do we call it util or utils? Util.head. Utils. How about that? Utils. We'll call it utils. You know what? I'll leave it around, and then you guys can go look at it. But I'm going to say, hey, go look for this other place. I'm not a fan of making utils packages that just have random crap in them. It's actually not idiomatic Go to do that. You should usually, pick something so that the package name reads nicely when it's combined with the other stuff. In today's stream, no, I don't ever. Why would I need to? So let's go ahead and do utils, and let's say, description. We'll say create a repository. So let's say temporary package. That's all, because I'm going to delete it as soon as we get done with this. I'm going to delete it. So you need to watch it and make your own copy if you want to do this, and you can decide where you want to put it. No, I don't want to git ignore. Do I want to? Or did I say yes? Okay, if I said yes, then you have to go find Go. I'm pushing the arrow keys down. We'll go find, where's my Go? CFG, Go. So here we go. Would you like to add a license? Yes. Apache is the best one because companies like it better, and you want to use your code at your company. That's the best chance of that is to use Apache. All right, so now we got all these things in here. I can cd into utils, and we have, this empty directory. Let's go ahead. So we know we're going to be working here, so now I can start up Tmux from this directory. I start up Tmux. I got a little bug in my bash RC there. That's okay. It'll go away. And clear that with C. I'll just clear it out. All right, so, and then we need to make a new repo, right? So let's call this one, well, I don't know. How do you make a new Go project? How do you take a moment to remind yourself? So we do go mod init github.com RWXRob utils. It's almost always worth it to just bite the bullet and make a new Git repo for this because you're going to need to do it anyway. So it's better to do all that hassle. All right. So then we have utils file and we have no Go code yet, right? This is not going to be a command. And this is the kind of thing that we're actually going to be able to test from a unit test package. So we're not going to need to make a command in here, so we can just make it a package straight up. And so how do we make a package? Well, to make, I think from packages, you should name them the same as your as the main one. You should name it the same. And so we make a new file called utils.go. And we're ready to go. We might as well at the same time make a test file, utilstest.go. All right. So then when you go to the utils.test file, and that's I can't that's a big question right now. We've got a project. Maybe ask after the video's done. All right, so let's utils.test. So the package is going to be utils, but this is the test file, so we're going to utils._test. Do you guys remember why? The reason for that is because we're going to use example-based tests that are going to match other stuff. So let's see. Let's go. So you guys, come on, take the drama down a notch. This is why I'm not putting it on the stream, obviously. Let's do this. Let's do utils. I'm so glad. I'm so glad I did not put the chat on the screen right now. I would have had to throw this fucking video away just because I just swore. You guys chill out. All right, so let's do this. Package utils. So this one is package utils. And then what are we going to do? I have to time somebody out. I'm sorry. This is too crazy. Yeah. I don't know. Proper consistent answer on the internet, which working with structs. I mean, you can't find a consistent. That's an architectural thing. Yeah, he's just probably drunk. I'm guessing he's probably drunk. Okay, he's mad because he said some other stuff. You're fine, Green. Don't worry. All right, so you get drunk people on Twitch all the time coming in here and doing stuff. Sorry, YouTube. Okay, so utils.go. We have a utils.go. We haven't written any code yet, right? Strangely though, it passes tests because there's no tasks to run, right? He's just drunk, so we're gonna just time him out until he gets undrunk and says he's sorry, because he will obviously come back and say that. All right, so here we go. Over here, we're gonna say we need to make an example function. Now this is how you test stuff, okay? So we do example, and then we have to figure out what we're going to call it. Well, let's call it head. And I'm calling it that because that's the same name as the Unix command. All right. So, and what should our output be? So you have to put output in a colon. Don't forget the colon or it won't work. So, and then we have to say, we could say like 1, 2, we'll say we just want to get 2 of them now. And, we can do that. So our first is going to be just basic head test. So we're going to fmt println. So we're going to pretend like we're going to go get it. We're going to pretend like our thing works. We haven't even written it yet. And we're going to do utils.head, and we're going to give it the name of a file, right? So the path to our file is test data. I like backticks because they're easier to read, but you use whatever you want. Test data, and we'll say head sample. Or we could just say file. It doesn't matter. Some file, and that's going to be our file that we're going to put it in, and then it's going to print that out. Now we probably should. We need to decide whether we want to return an error or not with this, and do we want to return an error along with it if it can't get to the file? Or do we just want to log the error and not put any output? I think that's probably what we want to do, right? We probably want to we want to be able to use this thing pretty reliably. And so if the file's not there, we don't want to force people to check the error every time. We just want to say, hey, I just want the top of the file. And if there's nothing there, then, well, no, because then we wouldn't know if it actually got to the file or not. Okay, so if that's the case, we have to do this. We have to say lines, right? Lines error equals utils.hit. So this is test-driven development. We are thinking about how our thing's going to work before we've written any of it. And this particular type of thing lends itself well to test-driven development. Not everything does, right? So then we can just do fmt println lines. I don't like returning error, but it is really the idiomatic way to do this. So then we're going to go down here and just go read the about page. Comparing those two languages is a good, yeah. All right, so learn Go if you want a job. Learn Rust if you just want to screw around. So we're going to grab the first two lines. So we're going to say, I want head of that file and I want 2 lines of that file. Okay, so that's what we want to run. So let's run that and see if it works. We can actually split the screen here, and we can run this cool thing I wrote called go enter. This actually runs the test every time there's a change to the file, and it says, hey, there is no utils. I don't know what you're talking about because we haven't made it yet. So let's go make it. Package utils, right? It's like, oh, okay, but it doesn't even know that it exists even now. Because why? Because we haven't installed the package or anything. So, and we did utils_test. So the way to get around that is to go work init. Go work init, go work use dot. And that should begin to help us out. So we do utils.go, and right here we'll say func head is going to take a string. It's going to take a path to the file. So path string, and it's going to take an integer count, we'll say. How about n? N lines. We want n lines. And it's going to return, what is it going to return? It's going to return a slice or an array of lines, which are strings. And it's going to return an error, potentially. Okay, so there it is. We can go ahead and just return an error condition. So if it was an error condition, we'll return a nil. And we'll return... actually no, we'll assume it's we need the string. So return lines. Let's say we're lines. So we've got to declare a thing. So let's declare lines to be a string. And I like to start out that way. Now we got the guts. We got the body of the function that we still need to write. So here we go. So here we go. We got this. It says undefined lines. There's no such thing. Lines. Oh, lines. What was I thinking? That was like silly. That was an int, of course. We want n number of things, and so Utils is still having a problem here, and I don't know why. Why is our test having a problem? We have to go check it. Utils_test. Oh, we haven't imported it. There, we got it. See, so now when I saved it, it automatically added the import line for us because I didn't have it before. There was nothing there. And the reason it didn't find it before is because it had nothing to go look in. I couldn't go look at this H here and see. So now it sees it, right? It says it's undocumented, though, so let's go ahead and document it, shall we? Let's document it right now. So we're going to document it. We're going to say head return like Unix returns the top n lines of a file like Unix command. So like the Unix command. So here we go. There we go. So we've got errors declared but not used. Okay, so now we're starting to get some errors that we can use. So we're going in here. We got an error. Where's our error? Okay, we didn't use this error. So let's actually use that error. I've got a macro for this. So we're going to say if there's an error, let's go ahead and print it. This is just a test. Again, these example tests show up in the documentation. I'm going to prove it. So if there's an error, print it. Now, this is all ugly, but as soon as I save it, it gets linted and fixed up by my go command. That's why it looks pretty like that. So it prints it out, and there's no lines. Oh, no. Okay, so our test is failing, but it's actually running this time. So we're getting there, right? So now we need to actually do the work of this. So what do we need to do? We need to open the file open the file at path. Then what? Then we need to scan each line of the file. We don't want to load the whole file, right? Not load whole thing. Now, if we were going to do other things, so for example, when we're going to tail is going to have to load the whole file, right? Which is why tail is a lot less efficient than head, because the head doesn't have to open the whole file. It can just go right through the file. It doesn't have to. It can just look at the very beginning. So we want to scan each line of the file and increment count, and then return it, and then return. I mean, it's really not that hard of a thing. One of the main reasons I'm doing this, however, is because this is one of the recipes that you need to have in any language, right? So anytime you embark in programming in a language, there's like, a non-trivial number of recipes about how to do things. How do you open a file? How do you head a file? And you'd be surprised. A lot of the same things that you need to do are the same sort of things you would need to do from the command line in a one-liner in Bash. And so you end up coming up with this kind of collection of recipes and utilities. TAC is another one, yeah, so that you can do these kind of things, right? So one of the ways that I've done that is I've been porting all of my Bash, hundreds of Bash scripts in my dot files into a single monolith that I can just copy around anywhere using Bonsai. This is one of the ones that I needed to convert over. So you kind of just have to write them. It's a good practice, and so that's why we're doing it. So open a file. So how do you open a file? Well, I'm going to try to pull this out of my memory. This is the kind of thing you'd have to go read about, right? So you could do. I'll do what you would do. How do I open a file in Golang? So you don't really need a book. You can just go to the research, os.open file. What do you know? It's the first hit. How long did it take me? How long did it take me to get that answer? Not very long, right? Because I'm doing text-based research, which is using links or W3M. If you're not doing that, you're wasting time. Sorry. I hate to put it to you, but you are. So there it is right there. var file, and that's opening the file. Now that's opening it for read-write. We don't necessarily want to open ours for read-write, though. So let's go see if we can open it without read-write. I know there's a way to open it and buffer the whole file, but I don't want to do that. I just want to... That's like... I think it's just os.open instead of open file. Yeah. It is. I think I'm pretty sure it's just os.open. Yep. It's a built-in Go function that takes a file path flag and file mode as arguments and opens and reads the file. Let's import the package file. This is old. So let's do this. So mgo doc, and then we'll say os.open. So os takes a file. So that's old data, but it's good. And it gives us a file name. And file, I happen to know, implements IO reader, which is allow us to do the next thing. So if you didn't know what we were doing right now, you could just do this. You could say Golang read all lines of a file. So we do a little bit of research up front, right? How to read lines from text step by step. So let's go look at this first one up. Can't read that one. It's got JavaScript. So let's go find another one. Here we go. So there it is right there. There's our answer. And that's exactly what we're going to do. We're going to open the file. We're going to check for the errors. We're going to open a new buf.io scanner. So a scanner is something that iterates over a certain finite amount of thing. Like I've written a rune scanner. It goes, it scans every Unicode code point. A line scanner scans by lines. And this is one of the ways to make a file scanner. So now this one is reading the whole thing. It's getting the file and it's making a scanner, but then we can just scan each line. There are other ways to do this where we could read up the whole thing. And you also don't want to forget to close your file handle. So this gives us kind of everything that we're going to be doing, but I want you to understand what it is while we're doing it. So we're going to go back here and we're going to say, that's all in my terminal velocity book that I'm going to be publishing in May. You can stay tuned for how to do all this stuff that I'm doing if you don't know. Right, I've got a book started. I've also got a series of videos on how to do everything I'm doing. So, all right, so let's go. So var lines link. We're going to open this file path. Okay, so we know we need to have an open. So we know it's os.open, and we need a file. So we can go ahead and do the file path, and that's going to give us a file handle. So we could do file. I'll just do F, and we got an error, and we're going to have to return that error. If there's a problem with the error, we need to return it. And we're also going to return a nil because this is a slice. A slice is like an array and Go, and and it's actually on top of an array. So it's an abstraction on top of array that gets passed by pointer automatically if you know coding. So so error, and then it opens the path. We get our f. And so if we get past to here, then we actually have an f, and we can do something with our f, right? In fact, we can actually even just log it for fun. So let's log our f. Let's log our, oops, wrong one. Let's log, oops, wrong one. There we go. Let's log our f. I just want to show you the f. If you don't use it, it'll bark at you because like, you can't do that. You're not using it for anything. I'm like, okay, fine. So here, see what it said? Test data, some file, no such file directory. Okay, so our error is updated because we updated the file. Let's go actually add a file there. So make directory test data. And then we're going to edit test data, some file. And we're going to put 1, 2, 3, 4, 5. How about that? And let's actually wake up our file so we get a test. There we go. Hey, look, there's our file pointer. Our file pointer opened up. It wasn't nil. We didn't get an error. Just to give you a sense of what it would be like if we did have the error, though. If it wasn't there, I mean, let's change our test, shall we? Let's change our test to do something that doesn't exist. And we already saw this error. So there's the error, right? So that was the error printed out for us. So now we know what's up. But we added it back, and now our error is gone. All right, but this, you see how this logged it up here, and it's just standard error and not standard out, and so it's not messing up our test. That's why we did that. So if you want to look at stuff temporarily, you should be using log, not print. You should be using log in general if you want, diagnostic stuff to kind of go out. So there we have log.printf, and what do we have? We have we know we have a file handle. Yay. Okay, so now what do we want to do with it? Well, we want to read from it. So let's go back to the internet and do some research and read it. It says, okay, we got our file, we got our checking, and then we need a scanner. Okay, so buff.io new scanner. What the hell is that? Well, let's go read about it. So mgo.doc buff.io. Well, let's just look at buff.io. So this is all of buff.io. By the way, if you don't know what M is, let me show you. Type M. VICM. So this is what M is. M is my less, but it's basically just making so I don't have to pipe. That's all it's doing. Okay, so I can do this. I can say mdoc buff.io and I get a pipe without piping to more or less or whatever. It's kind of annoying sometimes to do that. So I just put it first. Because if you're having a hard time following this, I'm really sorry, but this is assuming you already know how to code in Python. You've already done several programming lessons in Go, and you're you know how to use the terminal and everything, and you've been through the boost. If you haven't done any of that, you can hang on as much as you want, but I'm making a lot of assumptions here about what you know. All right, so if you want to get those things, there's other places you can go to get those things. So we have the scan lines here, we have scan bytes, we have scan runes, we have all this awesome stuff that we can do for scanning, and we're going to need all of that. But so let's read about it. Let's read about buff.io scan lines. And so scan lines, what does it do? Date, Boolean, advanced. Scan lines is a split function for a scanner that returns each line of text stripped of any trailing end of line marker. That's cool. The return line may be empty. The end of line marker is an optional carriage return followed by one or more mandatory new lines. In regular expression notation, it would be this. The last non-regular of the input will be returned even if it has no new line. Please ask as many questions in chat. Please help out the newbies who don't know, okay? Because I can't. I'm kind of going at pace here. So here we go. Thank you for your help. Now, there's a problem here, though. This is actually bad code, and there's a lot of problems with this code. So this close should never be that far down, because if anything happens wrong in here, guess what? The close doesn't happen. It doesn't. So we're going to fix that, and we're going to put it in the right place. We are. Wait, I already did this one. So where are we? Okay, here we go. So whenever you open a file, you immediately close the file. Standard error. So we're going to do... we're going to say here, we're going to say defer. Now, what does defer do? Defer says whatever function this is, run it when the function that contains the defer statement exits for any reason. That means if there's an error and there's an early return here, this will still get run. It'll get queued up and stacked up, and then it'll run, right? So, what happens if I put a close down here? What happens if I put an f.close down here? and I have an error up here and I return it before hitting f.close. At least a dangling file open, right? So in order to get around that, that example that's out there is totally wrong. Okay, so you should do a defer f.close, and that will force it to close no matter what, even if there's an error, no matter what. So I love this thing about Go. You can put these defer statements right after the things to clean up the resources if they're left over, right? To make it easier to read, we could do something like this. We can do something like that if you want. You can put it like that if you want. It doesn't matter. All right, so the defer close is there. But now we need to actually do something with it, right? So we need to scan a line. So we need to get that buffer. Now, what is the buffer? This stuff is right. So we need a new scanner. So scanner, I'm going to call it S. I don't like doing fancy ass long names. They just make it harder to read the code. So I'm going to do S dot buff.io dot new scanner, and we're going to give it F, right? And this one is doing a split. I don't know if I actually want a buff.io scanner, because buff.io loads up the whole file. I don't want that. I don't want that. There's another scanner. Let's go see Golang line scanner without buffering. There's one that does not do buffering. Yeah, there's one that's a little bit better. Buffer limit and buff.io. I don't want a buffer. I think it's going to buffer it no matter what. I don't think we have a chance to get around it. Scanner equals new buffer. In file. Scanner. So scanner.scan. So by default, it does line buffering. Yeah. Yeah. In fact, here, I'll show you. So if we go read it, oopsie, buff.io. Why doesn't it know about it? Oh, there we go. Returns a new scanner to read R. The split function defaults to scan lines. Okay, so by default, the scan function is going to be scan lines. So we've got what we need already. We don't have to get too crazy with this. So then we can say this. We can say, and this is the idiom, my friends, for s.scan, do something, right? That is the idiom. And that says, scan it and then do something else. Whether you're doing rune scanning or line scanning, that is the way to do it. Now, and what it does is it puts the last thing scanned into a temporary holder. And so you can grab that thing by saying, what the line is, right? Now we can, how many of these do we want? We need to make sure it's only 9. So let's do an init check change. Okay. Anytime you're going to be looping, you got a number involved. You need to do an init check change loop. All right. So an init check change, or you get the init check change. So we need the initialization. So first of all, we need to create a number, right? And we really don't care about the number. So let's do for count equals. So this is the init, or I. You can do I. For I equals, this is the init. For I equals 0, right? So that's the init. What are we going to check for? Well, we're going to check to see if I is less than, not less than or equal, less than our n. If I is less than n, then we're good. That's the check. And then the change, I plus plus. We're going to add 1 to it, right? Now, every time we go through our this is going to ensure that we only get 9 reads, right? But how do we combine our scan read in here? Well, it turns out that you can actually put the s.scan in there if you wanted to. Now, we could also do something else. We could take all of our init check change loop out of here, and we can put it like this. We could say var, especially if we need the value later. So var I is an int, and we'll keep it down here by the loop. So that takes care of that. And then we don't want it to run anymore. So we could say if I if I is greater than or equal to n, I'm trying to decide. I'm like rethinking this. If greater than or equal to n, then we could say break. We could break out of there, right? And why would we do this instead? Well, so we can do that, right? So actually, let's go back to our other init check change. Let's go back to this. I just got an idea. So let's do I equals 0. Okay, so then we're going to say as less than n, and we're going to say s.scan. Okay, so we were able to do a scan, and I is less than n. Okay, so now we have a compound condition. Normally it would just be this. So this is, was I able to scan? Why do we need this? Because scan returns false if it's at the end of the file, or at the beginning of the file, or out of data. So we don't want, we want that to be first, right? If and it's less than n, then keep scanning. Otherwise, end, right? So let's do that. And then what? Then what are we going to do? Well, we're just going to add our lines to a lines buffer. Now, we don't know how many, actually, we do know how many lines we're going to have. We're going to have this line string, right? So, and we need to append to it. So right by default, that is not defined. So let's change lines to be something else. Let's change lines to be, we're going to make a slice of a specific size. We're going to say, I want a slice of strings that has 0 initial size and has up to, and is going to have a maximum of n size, because we know how many we're going to have. And this gives Go the ability to kind of guess about memory allocation and stuff like that. It can kind of organize itself a little bit better. We don't know the size of the string. If we did that, it would be even better. But so that gives us a pointer to a lines slice, and something that we can append to. Now that is a pointer though to a slice, I'm pretty sure. Oh no, it's not. That's not a pointer. I don't think does make give a pointer or a regular thing. Golang make. I can't remember if it's a pointer or an actual one. We're gonna learn about built-in make function usage. All right, let's go read about it. I can't remember. I gotta go read about it really quick. Type the size and capacity. Make types that makes up 2 arguments. Type its size, returns type of its argument, and returns the type of its argument. Return type of make function is type returns the type of its argument parameter. Make a link type, make int type like int. I think we're fine. Yeah, it's just it's new that does the pointer, and yeah, there we go. See, var student equals make. Yeah, okay, so that's fine. Our research confirms it. So now we can go back into here. We can say lines. We can say this. We can say lines equals, because it's already been initialized. Lines. Anybody who knows Go, how else could I have done it without make? There's another way to do it without make that is not as efficient, but you could have done it that way. S.text. So we want the text that came out of the scanner, and that's going to give us 1 and 2. You can see our test is already working. It's giving us 2 strings that are being written kind of weird because it's an array or a slice, and so it's kind of putting them one after the other, but it's still working. And so we got 2 there. Now, if I change the test, so we actually have just completed our problem here. This is completely done, and we have fulfilled the needs of the head. So it says 1 and 2, right? Now let's test it. I mean, we can do all kinds of variations on the test, but the example test is just to give a sense of it for the next person who's going to be running it. But if we did 3, we should get 3, 1, 2, 3. If we do 1, we should get 1. I get 1, just 1, and then we're going to do. How about if we do 5? What if we do 6 and there's not enough? Uh-oh, we got them all, right? We got them all. Well, let's actually do this test, shall we? So we have the lines, utils head. So actually, let's do this. Let's grab this entire function, YAF. So that grabs 12 lines of the whole function. We want another function now. We want another example. We want a head example that goes off the edge. Let's say over limit. Okay. Or how about this? How about past limit or something. So we're making another test, and this is going to deliberately be like 100. How about that? It's trying to get head 100. I mean, that obviously is not going to do a thing. So, and it fails, right? But let's actually make our test pass now so we know what it's going to be doing here. So let's go into our output, and we're going to make our output match. Now, I deliberately put only 1 word in the line tests because I knew that the output was going to be kind of a lie. I mean, if we wanted to truly test this, we would actually have longer lines and we would check for the line return, et cetera, et cetera. But this is actually confirming something else for us. It's confirming that it's not putting line returns on everything, right? So that is the thing. Now, this one up here, we only want 2. So let's say 2, and it should be 1 and 2. So let's go down here and change our output to be 1 space 2 and get rid of this other one here, and we should pass. Boom! Our head program is finished. We have our library. It's finished. It's done. We could actually put it into a command if we wanted to, and use it to get the first 2 lines of a file. It's actually not that hard with Bonsai to do that, but that's going to be for another video. Taking these things and turning them into actual commands that are not just libraries. Let's actually do the same though now for tail. And when we do tail, we'll finish the video. So tail is, as you can imagine, let's write our test case for it. We're going to do tail. So tail, we have example head and example this, right? Well, let's cheat. We're going to steal all of these, Y capital G, and we go all the way down to the bottom, and we're going to dump, we're going to change the word head to tail. Tail, tail, whoops. Change 4 over tail. Okay, then what? Whoopsie. Oopsie, I don't want to change that one. I want to change only the bottom ones. Tail, 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 oopsie, tail. All right, so same exact idea, except for we should put some stuff at the bottom, right? Now, tail 100 should give us the whole file, right? Because it's going to go up incrementally back to the whole thing. So that should be the same test. As soon as I say this is going to fail, because it's like, I'm sorry, I don't know about tail. And this one should be what, though? We already know that the last two files are 4 and 5, so we already know what this is. Let's change it. 4 and 5. So this is cool because as soon as this passes, we win. As soon as this passes, we win. We win the game. We win the coding game. So now we can do that. Utils.go. It's a test runner. This is using Go's built-in testing. It uses reflection and it looks for something. It looks for a comment called output with a colon or unordered output with a colon at the end. That's example-based testing. It also gets that those example tests show up in your documentation as well for free. So that's why I prefer them over the other testing-based tests. If you can get away with it, sometimes you can't. All right, so we got this head thing. We need something very similar to it. So we're going to copy the whole thing. YAF. That says yank outer or the whole function, and then P, we're going to paste that function in. We're going to edit this. We're going to say tail returns the bottom end lines of a file like the UNIX command. Okay, so tail, yeah. Did I screw that up? What am I doing? Am I doing it wrong? Okay, here we go. This is tail. Same exact arguments and everything. That's why I want to do these together. We still need to open everything up again. In fact, we could probably put all of that opening up stuff into another function if we really wanted to. You know, I don't know what that would buy us right now, but we could say, you know, we still need to have the error and everything. So might as well just leave it as duplicate. And so then we're going to go to fs-buffer.io.scanner. And we got our scanner. Okay, now here's the difference. Okay, we need the entire file this time, and this is going to be tricky, right? Why? Because think about it. When we have a file, when we're doing head, we just need to know the first few for lines, right? But when we do a tail, we have to get every line and count back. There's no way around that. We have to load the whole file. So this little loopy thing, don't need it. Don't need it. Nope. For s.scan, why? We need to scan every stinking line. This is why, you know, it does it quickly, but it's why it's there. So we need to scan every stinking line. So we failed our first example because it loaded all these lines that we don't have. So now we have to filter the lines out, right? And we have to say, well, okay, well, what lines do we really want? Well, we want n is the number of lines from the bottom up. So what is the index? This is very beginner stuff, but what is the index of the last line? So let's just guess. What is the index of the last line? Let's see. I'm going to do this wrong on purpose. 1, 2, 3, 4, 5. So it's number 5, right? Let's return a 5. Kaplooey, not working. Why? Why? Oh wait, we need to we'll do colon 5. We don't have a 5. It got all of the lines, right? Up until line 5. Actually, we just want the last line. So let's do 5 here. So put 5 and 5. That's how you get the exact line. Oh, we didn't get a line. There is no such thing as 5, right? Well, the truth is we actually want we want 0 counts as a number. counts as one of them. So we want the length of lines minus 1, right? So we want the length of lines minus, actually we can try to do, I wonder if that'll work. Let's try that. Oh, okay, so the length of lines is too much. What is the length of lines, by the way? Let's log it. Let's log it. Log the length of lines. I just want you to see it. So the length of the lines, length is a very lightweight thing. You don't need to ever worry about calling it. It has no runtime overhead at all. So, okay, so the maximum, the total length of lines is 5. And if the first index is 0, so that means 5 minus 1 is our maximum. So the index of the last item is 4, and approve it. So if I print 4 here, and this is a slice range. So this says take me from 4 to the end. Well, there is nothing else, so it is the last one. But we have it returning a slice, so we're gonna have 4. So there we go. But we don't want that, right? We want that would be the last one. Okay, so the last one. Well, how do we replace it with it dynamically? With the length of lines. So we go the length of lines, whatever that is, and then that's too much. So minus 1, and now we have the last one. But it's not just minus 1. It's minus 1 plus n, right? So we want the last one plus 1. As actually, we might be able to get away with just doing minus n. Because if they put 1, if they put 0, we don't want anything, right? So we can actually get away with n. Yeah, that's cool. Uh-oh. Why do we have a problem there? That is called an out of bounds memory exception. That means that we tried to do something, and I don't even know. Let's go see what's up with that. So let's log it. I know what's up, but we're gonna so reverse scan.go and master. Yeah, you can do that too if you want, but why would you do that though? It has to load the whole file. This is much more fun. So we're gonna do n. Now watch this. Watch what n is. Yeah. Okay, so we'll zoom in on this. So n is minus 95. So apparently minus 95 is kind of out of the way there. So the reason that failed is because there is not 95 lines, right? So yeah, it's going to read the whole file, I'm telling you. Some people are sending me stuff about the reverse scan that's already in there. But the problem is that it loads the whole byte buffer. Yep, there it is, right there. It reads the whole thing. It's the whole byte buffer read. So yeah. I wonder which one would be faster. Because we're reading it by line, as opposed to like reading the whole entire file into memory. That might be faster than reading it one line at a time. That might be faster, actually. Yeah, but this will work. This will work fine. So, because if you read the whole thing into memory and then you just go backwards scanning through backwards to get to different runes, you could do that and not have to read each line to get there. You could just like load up the whole file as fast as possible. Yeah, it's probably faster to do it that way. So I'm going to let you guys figure out how to make this more efficient, but this is the standard way that I would do it if I were just writing it really quickly. First of all, I don't write tail. I don't ever use tail for anything. I use head for everything. So, okay, so let's do this. Let's say, so it's not that, right? So we can say if n, now we're doing it by doing number and counting and stuff like that. Some of the other stuff that's more hardcore, what it does is it actually uses a scanner and it scans in reverse through the file negatively through each rune until it comes to those tokens. And then when it comes to a token, it keeps counting up and goes through it that way. If you want to do it that way, it's really fun. I love writing parsers like that, but it's like way, way harder than this in terms of logic. So let's say this, we can say this. So we can say if the, so let's do this. So let's say you can't reuse the logic of head. No, you can't. No, you'd have to, I mean, you could put a reverse scanner in there and then the buffer would just do the same thing. Yeah, I guess we could try that. Is there a reverse scanner already out there? Because there might be a function that already does the scanning in reverse, but and it sets the scanner instead of line scanner to be the other scanner. Does somebody know if there is one? Okay, so the way the scanner, just so anybody wants to know, when you set up a BuffIO scanner, you can set the scanning function. You can actually define the engine for the scanning. So we might be able to replace the internal line scanner with a reverse line scanner. And I don't think there is one. If you can find one, it would have to be, if we did that, it would be this. We'd have to do s dot something. And in fact, let's go look really quick. So if we did mgo doc m, let's see, go doc BuffIO, and we can go see scan lines. So there's scan lines. You can do sorting in reverse, but I don't think you can scan in reverse. Maximum scan token size, invalid, unbyte, error, all the stuff that comes here. Split function scanner equals new scanner. Yeah, as far as I know, the scanner you'd have to initialize the scanner by going to the end of the file. So that would have to be a scan function, which you could probably write. We could probably write a reverse scan function. You could probably do that. But there are other options out there. Let's just keep going though. So that might be something fun to look at. It's kind of an extra credit kind of thing. So, but we're just going to scan all the way through and count them and then just delete them, which is, their thing. So the reason we're having this big, ugly, hairy error down here is why? Because we're trying to look at stuff that doesn't exist. And that's the nature of that. And so the first thing we need to do here is we need to say, we need to fix the n. So if n is less than, if length of lines, if the length of the lines, if n is less than the length of lines, that means it's minus whatever, then what? Then then n equals the length of the lines. And I know you think that that's overkill because I should just do it once and get the length, but no, don't do that. Whenever you're using slices, always use the length because it gets inlined and it gets replaced with the actual value. It's just don't do it. Your programmer in you wants to do this. L equals len lines, and it's a bad thing. It's not idiomatic go to do that. And then you would just do L, and not to mention L is a horrible identifier. You should never, ever, ever use L as an identifier. Ever. Okay, so n equals length of lines. So this minus 1. Well, no, let's see. Length of lines equals length of lines. So that would be length of lines minus. Okay, actually, this is good. So this is length of lines minus n plus 1. I think it would be. The length of the lines be 5. So we want the last 5. So if we had like 5 and I passed 6, then the 6 is less than the length of lines is 5. Oh wait, if it's greater than the length of lines, duh. Okay, so there we go. Now it works. I got it wrong backwards. My logic was backwards. So there we go. We have our head program and we have our tail program, and you can go have fun with this. And I think Mossy's taking us down the rabbit hole there. There are other ways to do this, but this is probably the most intuitive. And for a beginner, this is if I was writing a bash script, this is what I would do, right? I would scan them all up and then I would count them because I already had to cache them up. Is it slower because it's reading each line by line? Maybe a little bit. I don't know. I don't know what BuffIO is doing under the hood, and that would be considered premature optimization in this case, which is a bad thing. We would want to not do that. We would want to get the code working, so we had the algorithm captured, and then if performance became an issue, we should go back to it and say, okay, maybe we need to pre-cache this a little bit. But in the case of like this kind of programming, when you're doing like systems programming and utilities programming, good chance you don't need that. In fact, Go fits a really nice space between kind of after and with Python. So you have Bash, which doesn't do, complicated things like Python would do or Go would do. And then Go is compiled, so Python is not. So that's kind of the thing. And then if you want to do, after that, if you want to do low level, high performance, I care about garbage collection and the size of my binaries and all of these little things, right? Then you're starting to look for C and Rust and stuff like that, maybe Java even. C sharp, stuff like that, right? So that's kind of the progression for what you should pick. The reason that Go is my favorite language is not because it's my favorite language, it's because it's the language I can get the most done in the fastest with the least amount of overhead when it comes to deployment. So I can compile Go and I can put it on any device that it'll run on, anything. That includes Windows, Mac, ARM, whatever. It'll run on anything. If I were to do it with Python, I'd have to install Python, right? And hope that I get the right version. If I were to do it with Java, I'd have to install a JVM to get it to work. If I were to do it at Rust, I could do it, but it would take me an extra, 2 days to write it because it's Rust. And even good people with Rust, I've seen Gamozo talk about this all the time. It's harder to compile. It doesn't have as many standard libraries. It's good, but it's good if you need it. And most of the time, Go covers what you need. And I've just shown that right now. So for my choice of tools, and by the way, there was a 4,000% increase in Go programming, but for hackers love Go because they can write stuff fast. They can make it transportable. They can embed a file system inside of their binary. They can do all of the things that they want that are practical. And so as a tooling language, it's really good. In fact, the only thing that's even come close to catching my eye in terms of tooling is Nim, and Nim is just not got the oomph with it, but it is a really amazing language, and it's actually C. So if you want another language to play around with that's in the tooling space, particularly for hackers and stuff, I would play with Nim before I would play with anything else. But make sure you learn C before that. Okay, so that's all I have to say about that, YouTube. So see you to the next one.